Hi everybody, this video is a tutorial, kind of a conversation about understanding the data that you're going to see when you are testing your sensors. So the first thing that you need to understand is when you run your test, the data that you get over on the left-hand side is good data, but it only tells part of the story. You're going to have to analyze your data to start processing and thinking about what variable or what one thing you want to change in order to improve the data for each one of those three criteria. So let me take you through a couple scenarios, okay? First thing is notice at the top left, it says design overview, and that's highlighted. Okay. You're going to be able to manipulate the information on your grid from this screen. You're going to be able to push on each one of those earthquakes. If you would like to study your earthquakes, you can still do that by clicking on study earthquakes, and that's where you're going to be able to manipulate the tsunami wave animation, which once you start to narrow down your plan will be really helpful to you. So let's go ahead and look at some of these examples. So once the tsunami has passed through, and this one did have a tsunami, a couple things you want to look for. Number one, each one of those sensors is marked. We've got a deep sensor, an earthquake sensor, and a shallow sensor. The very first thing I can tell you is two of those sensors didn't work. The earthquake and the shallow sensor didn't pick up any information at all. And so the very first thing that you need to do is think about, do you even need to have those there in that in those areas? I definitely would consider moving them one at a time. Figure out what you want to do first, okay? Remember, we can only change one variable at a time. Looking at the deep sensor, it has 0 detections, 0 false alarms, and 0 breaks. The false alarms and breaks are great, but it's got 0 detections. It's not picking up anything. In this situation, the deep sensor has been placed in the shallow, so that's not going to work. It's very expensive and it's wasted. So one thing that you would want to do is probably in this scenario, before you get rid of or move the earthquake and shallow sensor, move the deep sensor and see if that can give you some better information. All right, for this one, I'm looking and the shallow is placed in the shallow, the deep is in the deep, the earthquake's in the earthquake. That's great. My shallow sensor is showing a flag that shows me, and by the way, I don't know if I told you this, you're going to have to click on the sensors to find out that information, I believe, unless they change something this year. So the fact that it's detecting 5 tsunamis is great. The fact that I have 1 false alarm is okay, but if I have false alarms from other sensors, those are going to add up. I have 2 breaks. In your reading today, you read that if a shallow sensor is placed too close to an earthquake, it's going to break. So even if I wanted to keep it in that same grid, I could just move it so it's a little bit farther away from those 2 earthquakes. I could switch it over to the grid to the right just so that it's touching the line, that border line. So it's really close to where it was, but it's a little bit farther away. So this is one where I would suggest that you zoom in and really fine tune, finesse where you want to place that sensor. All right, so this one is reminding you that local tsunamis that don't hit Sri Lanka are going to cause a false alarm. So I need to I would click on each one of those and see where it says data sent. I can click on each one of those sensors and break down that data so I can see. I can which one is sending the false alarm. I guarantee you it's probably the shallow sensor. And this is where I can use that tool to go back and forth about where those waves are. Basically, if you could just zoom in, take that shallow sensor and move it away from the first wave of that earthquake, and even you guys, for a local tsunami, try and get it out of the second wave too. If you take that shallow sensor and move it to the right in any of those shallows, that's a possibility. You're closer to Sri Lanka. So that might decrease your warning time if you have a ocean-wide tsunami. What you could do instead is maybe try and finagle it down a little bit farther on the left. But then again, you have to be careful of those earthquakes too. So it's a really fine finessing kind of a thing that you're going to have to do. But move the shallow sensor. All right, now this is an earthquake that was a magnitude 7.6. It did not generate a tsunami, but it caused a false alarm. So what are you going to do? I would get rid of that earthquake sensor. It's first of all, when you guys mapped India, we recognize that there's no convergent plate boundary there. So there's really no point in having sensors there in that area. I would get rid of that. Okay, how about this one? This is an ocean-wide tsunami. It did hit Sri Lanka. And I can see that it hit on that, well, the first wave, second wave, third wave, right? Use that animation and find out which wave is causing the false alarm. I can also see here that I've got data sent from the deep sensor. That looks great. My earthquake sensor did not send anything. So do you need an earthquake sensor there? Is it picking up on something else? And then I can see the shallow one broke. And we talked again about how those shallow sensors, if they're too close to those earthquakes, it's going to cause a break. So you need to move that shallow sensor. Also, I'd be curious to move that tsunami wave animation and find out why that deep sensor didn't send data. How come we didn't get warning time for that? If the shallow sensor broke first, then the deep sensor is not going to be enough. Remember, in chapter 4, I think it was in that second section before you started analyzing, comparing and contrasting the sensors, it said if the scientists from the tsunami control center receive a warning, sometimes they wait to get confirmation from a second warning before they send out the alert, the warning. So if that sensor's breaking and the deep sensor is relying only on the deep sensor, the scientist may not send that. So it's a good idea to have those two sensors together because they work together, but they need to be moved. The shallow sensor needs to be moved. All right, hopefully this helps you. If you have any questions as you're running your test tomorrow, you can ask me and I can help you interpret the data.